to the world's elite billionaires and sports icons. A hypercar isn't just a vehicle, it's a high-performing financial asset. And Bugatti has just rewritten the rules with its latest multi-million-dollar masterpiece, the Tourbillon. Ditching the iconic quad-turbo W16 of the Chiron, Bugatti engineered a completely raw, naturally aspirated 8.3-liter V16 engine that revs to a staggering 9,000 revolutions per minute. Paired with a cutting-edge triple-electric motor hybrid system, it unleashes a monumental 1,800 horsepower, wrapped inside a Swiss watch-inspired analog chassis and built inside Bugatti's highly classified new production facility, La Manufacture. This isn't just a car, it is a street-legal kinetic sculpture engineered to appreciate and value forever. Before a single carbon fiber panel is laid inside a mold, before a single V16 cylinder is bored to tolerance, the story of the Tourbillon begins somewhere far less glamorous. It begins in a boardroom with a spreadsheet and with a very short list of names. Owning a Bugatti Tourbillon is not a transaction. It is an admission process, closer in spirit to joining an elite university or a private members club than buying a car. Only 250 units will ever exist, and each one is already spoken for, snapped up before the wider world even understood what the car could do. So who gets to buy one? Bugatti sales advisors do not simply take an order. They study a prospective buyer's existing collection, their public profile, their relationship with the brand, and in many cases their net worth documentation, before an allocation is even discussed. This is not snobbery for its own sake. It is capital protection. Every hypercar manufacturer at this level understands a brutal truth about luxury economics. A vehicle's long-term value is directly tied to who owns it, how it is used, and whether it ever reappears on the open market in a way that damages the brand's mystique. A Tourbillon owned by a serious collector who keeps the odometer low and the provenance clean is worth more, sometimes dramatically more, than one that gets flipped within a year by a speculator. Bugatti actively discourages that speculation. Buyers who are suspected of ordering purely to resell at a markup can find future allocations of any model quietly close off to them forever. This vetting process transforms a Tourbillon from a mere object into something closer to a certificate of belonging, an asset class with a gatekeeper. And in financial terms, that gatekeeping is exactly why the car works as an investment. Scarcity engineered by production numbers is common in this world. Scarcity engineered by relationship and reputation is rare, and is precisely what makes these 250 units function less like depreciating machinery and more like a hard, appreciating store of wealth, insulated from the wider used car market by the sheer difficulty of ever being allowed to own one in the first place. For nearly 2 decades, the beating heart of every modern Bugatti was the same basic architecture, a quad-turbocharged W16, an engineering marvel of force induction and brute complexity. With the Tourbillon, Bugatti made a decision that stunned the automotive world. They walked away from it entirely. In its place, it's something almost defiantly old-fashioned in concept, yet radically modern in execution. A naturally aspirated 8.3-liter V16, developed in partnership with legendary British engine builder Cosworth. No turbochargers, no forced induction lag, just 16 cylinders, arranged in a configuration almost unheard of in production road car, built to rev with the ferocity of a race engine. This engine screams to 9,000 revolutions per minute, a figure that belongs in the world of Formula One paddocks, not showroom floors. Achieving that kind of rotational speed in a naturally aspirated engine of this displacement required Cosworth to draw directly from motorsport. Inside the block, components benefit from plasma-coated cylinder linings, a technique borrowed from top-tier racing programs, reducing friction and allowing the internals to survive the punishing heat cycles of sustained high RPM operation. Titanium connecting rods and other lightweight internals shave crucial mass from the rotating assembly, because every gram spinning at 9,000 times a minute represents enormous rotational inertia that has to be controlled. The engineering logic here is almost philosophical. Turbocharging can deliver huge horsepower numbers with smaller displacement, but it does so by compressing air and managing lag, heat, and complexity through electronics. Bugatti's engineers, alongside Cosworth, chose a harder path: raw displacement, an enormous cylinder count, and mechanical purity, chasing throttle response and engine note rather than simply chasing a horsepower figure on a spec sheet. The result is an engine that doesn't just move the car, it performs, delivering a sound and sensation that no turbocharged unit can replicate. In an era where nearly every hypercar manufacturer is downsizing and turbocharging to meet efficiency targets, Bugatti built the automotive equivalent of a symphony orchestra when everyone else installed a synthesizer, and in doing so, they created what may be remembered as the final great naturally aspirated engine of its kind. A V16 alone, however extraordinary, is not what makes a Tourbillon 1,800 horsepower. That figure only exists because Bugatti fused a mechanical masterpiece with one of the most sophisticated hybrid systems ever installed in a road car, an 800-volt electrical architecture built not for efficiency in the way a hybrid sedan might use it, but for outright performance dominance. The system deploys 3 separate electric motors, a configuration engineers refer to as a triple motor matrix. 2 of these motors sit on the front axle, working independently of each other, while a third is mounted at the rear, integrated directly with the transmission. This is not simply about adding horsepower. It is about controlling where and how that horsepower reaches the road, in real time, thousands of times per second. Because the 2 front motors operate independently, the car can send different amount of torque to the left and right front wheels simultaneously, a technique known as torque vectoring. In a corner, the outside front wheel can receive a surge of electric torque, while the inside wheel receives less, effectively helping to rotate the car into the turn rather than fighting against it. This transforms a nearly 2,000 horsepower hypercar, a machine that could easily become a physics nightmare in untrained hands, into something engineers describe as remarkably composed and predictable at the limit. The 800-volt architecture itself matters enormously here. Higher voltage systems can transmit more power through thinner, lighter cabling, and can charge and discharge far more rapidly than the 400-volt systems common in most electric and hybrid vehicles. That means instantaneous torque delivery, with none of the lag associated with waiting for turbochargers to spool. The electric motors essentially fill in the gaps at low RPM, where a naturally aspirated V16 is still building its rhythm, before handing off seamlessly to mechanical engine as revs climb toward that 9,000 revolutions per minute red line. The combined output, 1,800 horsepower, positions the Tourbillon among the most powerful production road cars ever built. But the number itself almost undersells the achievement. What Bugatti has actually engineered is a car that behaves like a naturally aspirated analog machine at heart, with a digital, electric safety net woven invisibly underneath it, ready to correct, assist, and amplify at every single moment. To build a car this complex, Bugatti could not simply expand an old production line. They needed an entirely new philosophy of manufacturing, and that philosophy now has a physical address. La Manufacture, Bugatti's newly inaugurated production facility at their historic home in Molsheim, France. Spanning roughly 3,245 square meters, La Manufacture was purpose-built for the Tourbillon era, and stepping inside it, according to those few journalists and dealers who have been granted access, feels less like touring a car factory and more like walking through a precision watchmaking atelier scaled up to the size of an automobile. Every Tourbillon that will ever exist passes through this single facility. Unlike mass-market car plants running assembly lines that build hundreds of vehicles per day, La Manufacture operates on what's called pre-assembly and high-precision matching, where individual components, from suspension arms to interior switchgear, are custom-fitted to each specific chassis before final assembly even begins. Technicians here are not simply installing pre-made parts. Many components arrive as near-finished pieces that require hand finishing, meaning every single Tourbillon carries the fingerprint, quite literally, of the small team of specialists who built it. The quality control processes inside La Manufacture reportedly rival those used in aerospace manufacturing. Components are checked and rechecked at tolerances measured in microns, because a car engineered to survive 9,000 revolutions per minute combustion cycles and 276 mile-per-hour aerodynamic loads simply cannot afford margin for error anywhere in its structure. This is also, notably, a highly classified environment. Bugatti has been deliberately protective of what happens inside La Manufacture, restricting photography, limiting outside access, and treating the assembly process itself as part of the brand's mystique. In an era where automotive manufacturing has become almost entirely robotic and mass-produced, Even at the luxury end, Bugatti has bet that a return to hand craftsmanship, wrapped in secrecy and scarcity, is precisely what today's ultra-wealthy buyers are hungry for. La manufacture isn't just where the Tourbillon is built. It is proof, physically embedded in steel, glass, and carbon fiber, that this car was never meant to be mass-produced in any sense of the word. Step inside the cockpit of the Tourbillon, and the first thing you notice is what's missing. There is no glowing digital dashboard, no pixelated screen relaying speed and RPM through software. Instead, Bugatti and a team of Swiss watchmakers built something almost defiant in its mechanical purity, an entirely analog instrument cluster. And the car's very name is a direct tribute to that decision. A tourbillon, in traditional watchmaking, is a mechanism designed to counteract the effect of gravity on a watch's escapement, one of the most difficult and prestigious complications a watchmaker can create. Bugatti's engineers wanted their instrument cluster to carry that same level of horological obsession. The result is a gauge cluster built almost entirely from titanium, sapphire crystal, and ruby bearings, the exact same materials used in the world's finest mechanical timepieces. Every needle sweep, every flicker of the tachometer, is driven by actual moving mechanical components, not by a screen simulating them. But perhaps the most extraordinary detail is architectural. The instrument cluster itself does not rotate with a steering wheel. Instead, engineers designed the steering column so that the wheel rotates around the stationary gauges, meaning the driver's view of speed, RPM, and critical information never blurs or shifts during aggressive steering inputs. It is an almost absurdly complex mechanical solution to a problem most manufacturers solve instantly with software, and that is precisely the point. This cockpit is a rejection of the touchscreen era. In a moment when nearly every vehicle, from economy hatchbacks to seven-figure hypercars, has embraced massive digital displays, Bugatti made the deliberate choice to build something that will never suffer a software update, never freeze, never feel dated in 5 years the way a digital interface inevitably will. From a collector's perspective, this decision is financially significant. Mechanical objects age with dignity. Digital objects age with obsolescence. By building an interior with the philosophy of a Swiss watchmaker rather than a software company, Bugatti has ensured the Tourbillon's cabin will feel as extraordinary in 30 years as it does today, an asset built to be timeless in the most literal sense of the word. Beneath the Tourbillon's sculpted bodywork lies an engineering achievement arguably as significant as anything happening inside the engine bay. A structural approach that blends traditional carbon composite construction with genuinely cutting-edge computational design. The foundation of the car is a carbon fiber monocoque, the same fundamental construction principle used in Formula One chassis, where the passenger safety cell and much of the car's structural rigidity comes from a single, immensely strong composite shell, rather than a traditional steel frame. This approach has long been standard practice among hypercar manufacturers, but Bugatti pushed the concept further by extending advanced composite and additive manufacturing techniques into components that have traditionally been machined from solid metal. Nowhere is this more apparent than in the suspension. The Tourbillon suspension arms are 3D printed, and their internal structure was not designed by a human engineer sitting at a workstation manually drafting geometry. Instead, Bugatti employed artificial intelligence-driven generative design software, feeding the system precise parameters around load-bearing requirements, weight targets, and the extreme thermal and aerodynamic forces the car will experience at speeds approaching 276 miles per hour. The AI then generated an internal lattice structure for these hollow airfoil-shaped suspension arms, a structure that no human designer would likely have conceived on their own, optimized in ways that maximize strength precisely where load paths demand it while removing material everywhere else it is not structurally necessary. The result is a suspension component that is dramatically lighter than a conventionally machined equivalent, while still meeting or exceeding the extreme structural demands placed on it. At the speeds this car is engineered to achieve, every suspension component is fighting against aerodynamic forces that would tear apart conventionally engineered part, and the hollow airfoil shape of these arms does double duty, managing the airflow around the wheel wells while simultaneously providing structural support. This same philosophy of computational, weight-obsessed engineering extends into the car's broader aerodynamic package. Every surface, vent, and channel across the Tourbillon's body was refined not just for visual drama, but for genuine aerodynamic function, managing downforce, cooling airflow to the naturally aspirated V16, and stability at the outer edges of the car's performance envelope. At 276 miles per hour, the margin for aerodynamic error essentially disappears, and Bugatti's engineers approach that reality with a level of computational rigor that pulls techniques directly from aerospace design rather than traditional automotive engineering. The Tourbillon, in this sense, is not simply a car with impressive top-line numbers. It is a demonstration of how artificial intelligence and generative design are beginning to reshape what is physically possible in high-performance engineering, one hollow, impossibly optimized suspension arm at a time. Bring every element of the Tourbillon together: the vetted ownership process, the Cosworth developed naturally aspirated V16, the 800-volt hybrid matrix, the atelier-style production in side-law manufacture, the Swiss watchmaker-built instrument cluster, and the AI-optimized carbon structure, and what emerges is not simply a hypercar. It is a carefully engineered financial instrument, disguised as one. The hypercar collector market has, for over a decade now, consistently outperformed many traditional luxury asset classes, and vehicles that combine true mechanical rarity with manufacturer-controlled scarcity have shown the strongest and most consistent appreciation. Bugatti's own history provides the clearest evidence of this pattern. Early Veyrons, once dismissed by some critics as depreciating novelties, now regularly command significant premiums over their original sale prices at auction. The Chiron followed a similar trajectory, with certain limited editions appreciating dramatically within just a few years of delivery. The Tourbillon has been engineered from its very first design meeting to accelerate that same pattern. With only 250 units ever to exist, a production facility physically incapable of scaling output, and an ownership vetting process that filters out short-term speculators in favor of long-term collectors, Bugatti has effectively removed most of the traditional risks that cause luxury assets to lose value over time. There will be no expanded model year. There will be no larger production run responding to unexpected demand. The scarcity is not a marketing claim. It is a structural, physical constraint baked into the very facility where these cars are built. Layer onto that the fact that this V16, naturally aspirated, screaming to 9,000 RPM, will almost certainly be the last engine of its kind ever built by a major hypercar manufacturer, and the Tourbillon transforms from merely a rare car into something closer to a historical artifact. The definitive closing chapter of over a century of purely mechanical automotive engineering before the industry's inevitable and complete transition toward electrification. For the ultra-wealthy collectors who now own one of these 250 units, the calculation was never simply about horsepower or top speed. It was about acquiring a permanently fixed, mechanically irreplaceable piece of automotive history at the exact moment before that era closed forever. And as this car ages, decades from now, when naturally aspirated 16-cylinder engines exist only in museums and private collections, the Tourbillon will likely be remembered not just as Bugatti's finest hypercar, but as one of the most successful pieces of tangible financial engineering the automotive world has ever produced.